In our last lesson, we've been looking at different kinds of shapes. Specifically, we were looking at symmetrical shapes, how we can make different shapes symmetrical depending on the pattern, and we were talking about what's on one side needs to be the same as the other, almost like looking in the mirror. But this lesson, we're still going to be kind of focusing on shapes, but we're going to be looking at angles. We've already discussed what a right angle is, but we're going to be moving on, be talking about two more different kinds of angle and how we can describe and compare angles based on how big or small they are. Right, hopefully this helps. I'm going to do the video a little bit differently today. Instead of doing a video where I'm drawing it out on the paper, this one I'm going to be converting a PowerPoint because I thought it'd be a bit easier to show you. I'm going to talk you through the slides that you're going to be needing for today's lesson that I've put up on Seesaw. The learning objective for today then is to recognize acute and obtuse angles and be able to compare different angles. I'm not expecting you to know what these are yet, and I'm going to go over what another kind of angle is that we've already spoken about. That's right angles, but hopefully by the end of this lesson you will know what acute angles and obtuse angles are. Alright, to begin with, let's look at a few angles and compare some. Here's angle A, B, C and D. We're going to have a think about how big they are. Remember, the angle is that curved part in between the two lines. And here's angle E. Which of these do you think are bigger than 90 degrees and which do you think are smaller? Why do you think that? I'm going to give you a few seconds to, in your heads or on your screens, just have a think about which of those are going to be bigger and which of those are going to be smaller. Alright, we are going to go through those, but before we can go through them, we need to know what 90 degrees is. If you have a look at this picture here, the black two lines show the size of the angle, what we're measuring the angle between, and the red dotted line there, more specifically, shows the gap in between the two lines, which is the angle that we're measuring there, between those two black lines. The red dotted line there is really an imaginary line to help us think about where the angle between those two black lines is. If you have a look here, the two black lines make a sort of L shape, like that, or maybe like that. That works better. They make an L shape between them. We call this a right angle when they make an L shape. It needs to be exactly an L shape though. It can't be a bit bigger and it can't be a bit smaller. You should be able to fit a square in the corner of that L shape. If you have a look now, I've drawn a little red dotted square between those two black lines because that shows you that it is exactly 90 degrees. If they were a little bit bigger or a little bit smaller, it might be nearly a square, but it wouldn't be a square exactly, so it wouldn't be 90 degrees and it wouldn't be a right angle, even if those two black lines were slightly bigger. Okay, so if you have a look on this screen, what you should be able to see is that I've separated the angles that are smaller on the left hand side. I've separated the angles that are smaller than the right angle, and if you have a look on the right hand side, we've got all the angles that are bigger than the right angle. So going to this, showing you like this, on the left hand side we've got all the ones that are smaller, and on the right hand side we've got all the angles that are bigger. If we have a look, we've already said this is a right angle and that is 90 degrees exactly. We're now going to look at what we call an angle that is bigger than 90 degrees. If you look now, we can see that it is bigger. We've opened that up. We started with, I get two pencils to help show this. We started with 90 degrees. If we make it bigger, like that, it becomes an obtuse angle. That's any angle from here getting bigger and bigger and bigger. Any angle in this bit, these are all bigger than that.
That's the right angle, that L-shaped angle. Anything bigger than that we call an obtuse angle, an obtuse. Remember that, it's one of the two words that I want you to take away from this lesson, obtuse. The next one, we start with that right angle. If we get smaller, we call it an acute angle. One way that might help you remember this is if you think little animals like bunnies and squirrels and rabbits and mice and things, acute because they're small. So acute angle and an acute angle is an angle that is small, and that's anything that's smaller than that. As soon as it starts getting smaller, that's acute, 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 that's acute. All of these are smaller all the way up to there where it becomes a right angle, and then if we kept going it would become an obtuse angle when it's bigger. So right angle, acute, right angle again, obtuse. Anything bigger than that right angle becomes obtuse again. Right, so if we go back to those angles that we started with, we've got our right angle here, and we've got an obtuse here because it's bigger, acute because it's smaller, obtuse because it's bigger, and this one over here, number C, is going to be acute because it's smaller as well. So which do we think is the biggest and which do we think is the smallest? Let's have a look. Before we can decide which is bigger and which is smaller, we sort of need to level them up so that we can compare them. To do that, what we're going to do is we're going to have one side, one of those two black lines, flat, because then we can compare the size. Let me show you what I mean here. So there's A, B, C, D, and E. Now that what we've done, if you look, we've put the bottom line of one of those two lines. We could have really chosen either lines as long as we leveled them up. We put one of those lines flat so that we can measure the size of those angles. Now we can try and see, so I've covered up a bit of that box, but what it says is now that we've leveled them up nice and flat, we can see them more clearly, and you need to decide which of those is the biggest and which of those is the smallest. So I'm going to give you a few seconds to have a think about that. Now we can see them more clearly, which is the biggest, which is the smallest. What we can do now, if it's not clear, we can put them over the top of each other. If you look here, we've put angle A and angle E over the top of each other so that we can see them. We can see now, because they're roughly the same size. If we put A on top of E, we can see, if we look here, we can see the angle, we can see that angle A is slightly bigger than angle E. Alright, so we found the biggest one. What you're going to have a go at now is naming some of these angles. If you have a go at the worksheet that I've uploaded onto Seesaw, what you'll see is a sheet that looks like this. You need to label each of these angles. It will either be a right angle, if it makes that L shape. So if it looks like this, that would be a right angle. If it's any smaller, all of the angles that are smaller than that are acute. Remember, acute is something small, something that's acute, but it's acute, an acute angle. And then if it's bigger than that, it's going to be obtuse. So anything in this range, all the way up to that 90 degrees, that L shape, anything bigger than that is going to be obtuse. So you've got acute, smaller than 90 degrees, right angle if it's 90 degrees, making that L shape, and if it's bigger than that, it's an obtuse angle. Right, hopefully that helps. If you need a hand with anything, just drop me a comment or send me a message and I'll try and help you out with it.